Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing stacks topic, and today following the monotonic stack pattern we will do the third question, which is daily temperatures. So let's read the problem statement. It says we will be given an array of integers called temperatures, and it represents the daily temperature. We have to return an array answer such that answer of I is the number of days you have to wait after the ith day to get a warmer temperature. Okay, so as you can see the temperature's value, correct? So basically if you are at this like I is equal to 0 index, so what is the current temperature? If you see 73. Warmer means कि the future like upcoming temperature need to be greater than 73. Then I can say कि yes, you are warmer than me. Yes. So you have to return the answer array in which every index will contain the exact number of days you have to wait to get the warmer day. So if you are at 73, can I say just the next element, which is 74, is warmer? So basically how many days I have to wait? Can I say 1? Okay, so that's why answer has 1. Similarly for 74, next is 75, which is warmer. Yes, so number of days you have to wait, again 1. Yes. Now for 75, if you see, for 75 next 3 elements are 71, 69, 72. All are smaller, and the next element, which is 76, is the next warmer. It means if you are at 75, you have to wait for 4 days, and so on. Similarly, if you see for 76, as you can see, there is no such warmer day, means you have to give 0, and similarly for 73, no such warmer day, means you have to give 0. So let's read the constraints now. Constraint says ki array length can go till 10 power 5 from 1. Okay, why this constraint matters? Because we will get to know ki whether our brute force code will work or it will give us TLE. Anyhow, you have to learn ki how to optimize, but reading the constraint is important because you will get to know ki if the constraint is larger, means brute force will give you TLE. In this case, n is 10 power 5. So if you are planning to give n square solution, we don't know what it will take, but mostly brute force is n square n cube, right? So even if you are trying to give n square solution, this will give you 10 power 5 multiplied by 10 power 5 means 10 power 10. And we know, if you are following me, beyond 10 power 8 it's not safer, and 10 power 9 onwards, so for sure it will give you TLE, correct? Yes. So as 10 power 5 n square will give you 10 power 10, so it will give you TLE. But let's see the brute force approach. How can we approach the problems? And then we can see how can we optimize it further and which data structure we will use here. So as you can see here, the temperature array, we have to run such that after 73 I got 74. Okay, so basically can I say basically I have to give the difference only, means if I am here 0 index, 1 index, 2 index, 3, 4, 5, 6, 7. So for 73 we got 74 next element, and the difference in the indexes is nothing but my answer. For 74 also difference is my answer. For 75, 76 is the answer, na? So 6 minus 2 means 6 minus 2 means 4. So means 4 is the answer. Yes. For 76 you have not got anything. Okay. So can I say the answer integer array, which I am going to initialize to return in my final answer, can I initialize everything with 0 only? Correct? And I will just run 2 for loops saying for this ith index I want next greater element. So just let's move this output part somewhere else. Let's say here. Okay. So what I can say, if I am at I is equal to 0, for I0, I want my next greater element. Okay. So can I say I'll start running my J loop? I cannot start from J from the same index because I have to give the warmer temperature from the next index onwards. So I'll start running my J loop. Okay. I'll start running my J loop. I'll say if the array of J is greater than array of I, I'll stop. Okay. And the index difference, which is J minus I, is nothing but the number of days I have to wait. Yes, correct. Yes. So for 73, I found 74. So I'll just put the difference in my answer array, correct? And I'll break the for loop. Means I don't want my J to move forward, correct? Why? Because for 73, I wanted the like first warmer temperature, I got it, then why will I like to move forward? Correct. So now what I'll do, definitely we will move our I to next. Now for 74 I want, similarly I have to start my J loop from next index. Now I'll find key yes, 75 is the next warmer temperature for 74, J minus I, which is 1, means I have to wait for 1 day. Correct. Now again I'll break the for loop for J, correct, and I will move this I forward at 75. Now for 75 we will start our J loop from here, correct. We'll check if this 71 is greater, no. 69 is greater, no. Now we will move this J forward, correct, because we are actually moving the J forward until we found any such value at jth index is greater than array of like temperature of I. So for 75, 71 is not greater, 69 not greater, 72 not greater, 76 greater. Okay, wait, stop. What is the index for 76? 6. What is the index for I? What? 2. So basically what we are storing, J minus I, which is nothing but 4, 6 minus 2, which is 4. So that's what we saved. So in answer array, at what index you will save the answer? Means difference is the answer, but at what index in the answer array you will save? As per J or I? Definitely I, because for I we are searching the next greater element. Okay, okay, done. So basically I can say yes, I can write this code using 2 for loops. First though I will initialize my answer array, and I will run the 2 for loops for int I is equal to 0 to I less than temperature dot length, yes, and I plus plus. Okay, got it. Okay, but as we are starting our J from I plus 1, if you remember, okay, so I can't let my I run till last index, because if you allow that, we like J plus 1 means here, correct. So it does not make sense. So why not to stop our I at second last index itself. Okay, so minus 1. Now we want to run our for loop int J is equal to I plus 1 to J less than temp dot length. We want our J to go until last one, correct. Yes. Now what we'll do, can I say ki if my array temperature of J is, if this is greater, not equal to also, because warmer means greater. If this is greater means I can say ki yes, I found the warmer temperature. So in my answer array at ith index, I have to put number of days I waited, and that is nothing but the difference of indexes. So I will do J minus I, correct. After this, once I save the answer, I don't want this J to move forward, so I will break this. Okay, break this. Now this for loop, internal for loop for J will get break, and now I will move forward initializing the J for the next index, which is from the next index, correct. So if you see the time complexity in this case, like after coming outside the both for loops, na, like here, if you'll come out and you will simply return the, you can simply return the answer. Yes, like this code is enough. But what is the time complexity? If you see, you run your I from 0 to last index. Yes. And for every I, you ran your J from I plus 1 to last. Okay. So if you see this, this is nothing but nested O of n into O of n, which is O of n square, correct. And we saw n was 10 power 5. So n square will become 10 power 10, which is greater than 10 power 8, correct. Yes. Or 10 power 9 for sure. If you want to check 10 power 9, means this will like definitely give us TLE. Means this code, even if we'll try to submit now, this will give us TLE. Okay, so I have written whatever we discussed. First calculated the length of temperature and initialized the answer integer and filled everything with 0. Now we will run 2 for loops. First for loop for I from 0 to n minus 1 also we can run, and second for loop from I plus 1 to last. At any time, if we found the jth index value greater than ith index value, then I can say yes, we found the warmer temperature, and at answer of I, we fill the difference and we will break that, because going for we don't want the j to move forward once found the greater temperature, correct. At the end, coming outside, we can return our answer. Now let's try to submit this, and definitely this will give us TLE, because the time constraint is 10 power 10 as expected TLE. Okay, so we need to reduce this. Now what pattern we will apply, or what data structure we'll use? Can I say key here in this, for this question, for every index, just to find the greater element or smaller element, we are actually running for nn size again. Can I say this? Yes. So for every index, I am starting my jth loop from I plus 1 and going till n, only to find greater element. So remember, if you are doing this, like at any index, if you are going forward or you are going backward again and again, just to get the greater and smaller element, means we can blindly apply stack data structure there. Okay. Yes. So now if you know stack, you know 4 standard problems also. Next greater element to left and next smaller element to left. Similarly, next greater element to right and next smaller element to right. Correct? But here if you see, for every value, we want greater element or smaller. Warmer means greater. Okay. And towards left means we are talking about future, not past. Remember, if in the same question it says past, means it is talking about next greater element towards left, but here it's talking about next greater element towards right. And if you are following our playlist, we already have discussed 2 previous questions on the same pattern, where we have discussed the whole code key, how we write for stack pattern, but still here I'll write it again for you. And if you know this, you can simply skip this. So the idea is very simple. For every index, we want to see greater element towards right side, correct? And if we want to start with the same logic, definitely we will end up writing the same for loops again and again. So like there are 2 ways. First, if it is about next greater element towards right, always start from the last side to to understand more better. What? For 73, you will maintain a stack also. Okay, stack. Okay, and as you found 73, so for this you will maintain stack such that keep for 73, either stack top will have greater element or nothing. Okay, means if stack contains smaller, then it will get popped out. So here for 73 we have nothing, so means we will not put anything for this index in our answer. Okay, similarly after this 73 will get inserted. Now we are at 76. For 76 we will go in the stack and we will see, hey, are you greater than me? 73 will say no, I am not. So means we pop this, and now for 76 also we will put nothing in our answer, and now 76 will get inserted in the stack. Okay, so this is a basic idea. Okay, again we'll move at 72. 72 will say, hey, are you greater than me? 76. So means if 76 is greater, we will not go inside the whole stack to find which one is the more greater one or like anything. So 72 will say 76 is greater. Okay, pick this up, correct? But here we don't want greater value. We want like similar idea, but we want the index of that. Can I say this? So if I am at here, I know the index for this 72, and if 76 is there, so why not to do one thing? Instead of 76, let's insert the index for this. We can do that. So we will insert the index instead of directly inserting the element. So we can directly read na ki suppose this is I. So we will read ki yes, if temperature of ith element is smaller than what? Temperature of I want index. So stack dot peak. If it is so, means this is a greater element. So for 72 location means I at ith location we will say the difference. How? This stack dot peak, which is 6, minus I means 5, which is 1. Yes, got it. Now again 72 will get added. 72 means index 5 will get added. Now we will move the 79 ahead. Now for 69. For this 69 we will see the index is 5 and 5th index value is 72, which is greater. Similarly 5 minus 4 we will do and we will write difference 1. Now 69 will also get added, means directly index. Okay. Now we will move to 71. What? Now 71 will say the index value for 69 is a smaller, means I want to pop this. Okay, if I don't want, means I'll pop this. Okay, but why we are doing now? Because 71 is greater than 69, then for any leftmost element in this part, okay, if they are smaller, means 71 will be greater. 69 will never be greater for those values. So hence 71 will always stand there saying I am greater, choose me, means 69 we can remove. So hence we will remove 69 as removed. Now we will add this 71 in a stack, means third index. Okay, now we'll move this I index ahead at 75. Now 75 will say stack dot peak, third index value 71 is smaller, means for any index towards my left, means 73, 74, I will be greater, 71 will never be, and that is true also. So hence why not to pop this? Okay, let's pop. Okay, similarly the next value is 5th index. Okay, so 5th index means we will go here, 5th index means 72. Again 75 will say, hey, 72 is also smaller, means they can't be greater than you, like greater than me. For all the leftmost value, either I will be greater or like going forward, not these one, because I checked in the stack. Okay, so now what, for 75 we will also remove this 72 which is at 5th index, so we will remove this. Now for 75 we will read the 6th index value which is 76, and hence 76 is greater, so we will, for 75 we will read the index 6 minus ith index 2 which is 4, at I we will put this 4, done. Now 75 which is 2 index will get added and we will move this towards left side. Now 74 will say ki yes, this second index value is greater, so let's directly write the difference which is 1, and similarly 74 means first index will get added here and we will move this at 73. Again 73 will read here, first value which is 74 is greater, difference is 1, 1 will get put. Okay, now if you are thinking ki yes, for 75 also to we run here popped n square only. If you see this, let's try to see this with the code. Okay, whatever we discussed now, we already have written this in the code also. So this is the code we just discussed, the dry run here, and here first we'll initialize the answer and stack as expected, and now we'll start running the for loop from the right side. Okay, one by one we'll pick all the elements, and to compare or to pop anything, first stack need not to be emptied. But if you see for 73 last element, okay, obviously stack will be empty, so this won't run. Okay, now we'll check if stack is not empty, again empty. So in the stack we'll put ith index, and what is I means last. So for stack, like for last index we have not inserted any waiting day, and anyhow for 73 we have not found. So 73 last index will get added. Similarly we'll now from the next time means 76 we'll check stack is empty, no it is not. So now it will compare key temperature of stack dot peak. In stack topmost element will store the last index, and if we will read this like temperature of stack dot peak 73, and if this 73 is lesser than this, so definitely 76 will be greater for all leftmost elements, 73 can't, so hence it will pop that, correct. So in this way whatever we discussed you can follow the code, and if you still confused, I don't think you will be, but still then I will definitely recommend the previous videos to watch, because one by one we have, like how I have showed you the dry run, one by one along with dry running I was writing the code also. Okay, so I hope you will get that and you will see that video if you are feeling confused. Okay, now the question is, why only like from right side? Can't we do from left side? You can, but the only difference is when you were doing from this side. Okay, for ith index, suppose if you are 76, you had the index which is greater for 76, so it won't. Suppose you are at 72, if I am at 72, so for 72 I found from stack ki yes 76 is greater. Okay, so for ith index itself I can put the difference in my answer. Okay, but if you will do from the right side, this won't be similar. Why? Because suppose if you are 73, so in stack you will put 73. Okay, in stack you will put 73. Okay, because for 73 you did not had anything, so you will move to 74, because the idea is you want to do in this linear, correct. So don't look for 73 go and find, no, if you want to do that start from the right side, but for 73 you will just put, because in stack you had nothing. Okay, now for 74 what you will do, 74 is your current element and you find ki hey, I am greater than the kept stack kept element which is 73, assuming we are storing the index. Okay, it will say yes I am greater. So can I say for 73 74 is a greater element? Yes. So means now in the answer variable we will not put at ith index, no, we will put in answer array we will put this index, at this index means 0. So at 0 index means stack dot peak, we'll write this like this, ki answer of stack dot peak at this index, correct. We will put what? We will put difference which is I minus stack dot peak. Okay, the only difference is this. Okay, whole code will be same, but the only difference is when you are writing from the right side at ith index itself you can write the answer, but when you are writing from the left side at stack dot peak value you will write that code. Okay, so I hope you understood this code. This was in Java, and let's try to submit this and this will be faster solution. And if you want to see calculate the time complexity, definitely we are running this for loop I from last to 0 or 0 to last O of n. Now if you are thinking for this while loop nested O of n square, no, see it, like, you know, in worst case also what's happening, you will end up popping everything from the stack, but only once. Now you are not going to put the same element again and pop it again. Are you getting this? Means when I was at here, like I was moving ahead, okay, similar time, like you inserted the 73 in the stack, okay, next time 76, next time 72, and so on, and whenever you encountered a bigger number 75, you popped. That's what you did, correct? But did this ever happen ki after 75, encountering 75, you popped from stack, and now when you moved 74, 75, 71, 60, like all these numbers again get added? No, na? Means you popped every element in worst case only one time. Means in worst case O of n will get added in the stack, and O of n times you will pop it, correct? Means it's not like ki for every ith index you are popping for n times, no. So means in worst case O of n plus O of n, in worst case O of 2n, which is linear only, okay. So this was the Java code, and here is your Python solution. Same approach, same code, language differs, and here is a C++ solution if you are from C++ background. So I hope you understood the logic of brute force and optimized, and also when we are talking about next greater elements towards the right side, why we prefer starting from the right side itself. It does not mean we cannot start from left, which is I is equal to 0. We can use for the difference now, okay. I hope it's clear now. So if it is, with this hope you understood, we can mark the next question, done. And I hope you will mark that only after submitting the code on your own. So that's it guys. I hope you like the video if you understood, and comment understood or submitted if you actually understood. And subscribe the channel please if you have not subscribed yet. And if you feel this playlist and the pattern wise sheet is helpful for your friends also, then please do consider sharing the channel with them. And the link of the sheet and the link of my social media platforms, I am very active on Instagram and LinkedIn as well, so please you can get the links from the description below. And that's it. Let's meet in another video with some more interesting questions and topics. Till then, keep learning, take care of yourself and your family.